Salam and greetings. My name is Clerence Lewin Champin and my matrix number is 203240. I'm studying in engineering in computer system and communication in University Putra, Malaysia. So today in this video, I will present and explain the first lab assignment on the course of ECC3118 Microprocessor. So the first lab assignment was given on how to write a code or also run a simulation by using RISC-V Emulator. So in this, my task was to run using an ECO-/addition to understand the changes in register content. And next I have to write a program where in this program, I'm supposed to use RISC-V assembly language to find an average of four numbers, not five. So instead of five, we are using four numbers only for this lab assignment. Now, it was given here the RISC-V emulator link. So when I press this link, you will be brought here. Now, since the first step, I have to use the ECO addition. So we press the ECO stroke addition, and we remain this as instruction. Now, note that this one is adjustable. You can be edited, right? So and one more thing that we have to understand is the assembly language is this link where you will be directed to this. In this link, you have to understand the usage of all instruction and also the 32 integer register. So in this lab assignment, I will be using the x0 until x8 integer register, where each of these integer registers has its own meaning. And also, since I'm looking to find an average for numbers, so the instruction that I'll be using for this lab is ADDI, ADD, and also SRA. So we have the ADD, ADDI, and one more we have the SRA. It's supposed it's here, where SRA used for arithmetic shift right with sign extension. Now, without further ado, since this instruction can be adjusted, so I'm looking for an average number of four data or four numbers. So after I key in, this is the coding that I have come up with, that I get. So we have 4 instruction of ADDI, 3 instruction of ADD, and 1 instruction of SRA. So all these total 8 lines of this coding will get the average of the numbers of 4 numbers that I've come up with. Now, don't forget to set my animation on and also adjusting the speed. Now, I will run this coding. So we press run. The code will automatically processes throughout this coding that I've written. Now, one good thing about this coding is that the code or the system goes goes by the coding line by line. So if you look here, it will process the first line and then it will produce the data on the line. So on the third line, it will put the data on the x2, the fourth it will be x4, and it will go so on until it will stop at the very last line of the coding. Since my coding ends at x8, so therefore by x8, it should be my final answers. So I'm going to pause here for a moment. All right. Since my SRA is x8, which is on the last line, therefore on my general purpose register here, the last line I had is at this point, right? So we have 0000036. Now in this simulation, in this general purpose register, all the bits or the binary number, all these registered now, all these numbers are represented in an hexadecimal. Since my coding ends at this line, the 8th line, so I only will have to find out the last line of which is the located at the x8. Now, if we were converting the 0000036, which is hexadecimal, into decimal, right, you will get 54. Now, how do we know that if our coding is correct? Since the first lab assignment requires us to find average of 4 numbers, so we look here to understand that the instruction of ADDI and ADD, where it will sum up all the values of the data in it here. So since there are four numbers that we're looking for. So I use the ADDI instruction to compile all the four numbers, and then I use an ADD since to continuous adding the numbers all up and average them using SRA. And um, when you add all this data, in total, you will get 217, right? Since there's only four numbers of four data that I'm using to find an average of. So this 217, the total of sum up of this coding, divided by 4, and you will get 54.5. So which equivalent to the decimal of the hexadecimal 000036, which converted into a decimal, you get 54, which equivalent to the coding or the instruction of your program here. And therefore, the lab assignment for this, the first lab assignment is successfully run by using this coding that I have written. And that's it for my first lab assignment presentation. Thank you so much.